The question we are solving now belongs to test series 7. It is of digital electronics subject. In specific, it belongs to counters. As per the question, there is a cascaded arrangement of the counters as shown in the figure. The counter 1 is a mod 3 counter and the counter 2 is a mod 2 counter. Output of the mod 3 counter is given as clock to the mod 2 counter, and the output of the mod 2 counter is measured as the final output, and the clock to the mod 3 counter is at a frequency of 12 kHz and it has a duty cycle of 50%. We need to measure the output frequency and the duty cycle of the output signal. From the given cascaded arrangement of the counters, we see that the circuit, the equivalent counter circuit, can be drawn as shown in the figure. It is the cascaded connection of the flip-flops as shown. The output QA of the first counter is given as the clock to the counter 2, and the output QB of the second counter is given as the clock to the third counter, and the output of the third counter and the second counter is fed to a NAND gate, which is given as the clear signal to all the three counters. So from this we see that in the given circuit the clock is at a frequency of 12 kHz and it has a duty ratio of 50%. So from this information we can infer that the output QA and the output QB are at a frequency of 12 divided by 3, that is 4 kHz, and they have a duty ratio of 33.33%. This can be inferred from the equivalent waveforms of QA and QB. And finally we can say that QC is at a frequency of 4 divided by 2, that is 2 kHz, and it has a duty ratio of 50%. So from this we can say that the cascaded arrangement of the counters has an output frequency of 2 kHz and duty ratio of 50%. Hence the correct option is D.